Welcome back, students. In displacement reaction, as you know, a more reactive element will displace a less reactive element from its solution. So for this experiment, we will be taking copper sulfate, that is CuSO4. So let us open it up, and using a spatula, we are not going to weigh it. We take a test tube and we add our blue colored copper sulfate crystals, approximately a spoonful of it into the test tube, and we keep this aside. So now what we are going to do is we have to make a copper sulfate solution. So this copper sulfate crystal we will dissolve in distilled water. So we add water to it. Now it becomes a aqueous solution, and using a glass rod we stir it till the time it is completely dissolved. So that is how you make a solution. In this case, copper sulfate was the solute and water is the solvent. Therefore, it is called as a aqueous solution. So, stir it completely. If you require, you can add a little more water, just a little more water to speed up the dissolving process. And there we have it. We have our aqueous copper sulfate solution. Now we need a more reactive element than copper. We take our zinc metal, zinc Zn. It is a highly polished silvery colored element. So we have to add this zinc to this copper sulfate solution. So we are going to add it. And we will set it aside. After around 45 minutes, we see that the blue colored copper sulfate solution has changed into a colorless solution, and also copper deposits can be seen at the bottom of the test tube. Now let us represent the chemical reaction that we just witnessed, that is your displacement reaction, with the chemical equation. In the reaction, we took copper sulfate aqueous solution, copper sulfate, writing the state symbol, aqueous solution, which was blue in color, and to copper sulfate we added our zinc metal Zn, which was in solid state. And after few minutes, what did we observe? We observed that the blue colored solution had become colorless, due to the formation of a new product, that is zinc sulfate. And at the bottom of the test tube we saw that there were reddish brown sediments of copper. So that is our displacement reaction. A more reactive element displaces a less reactive element from the solution. If we have to represent a general form of displacement reaction, then we can represent it as, let us say this is AB. Copper is A, sulfate is B. together it forms a compound AB. To that, if you put another more reactive element C, what will we get? We get BC or CB plus A. So this is the general form of displacement reactions. For the next type of chemical reaction, that is double displacement reaction. So for double displacement reaction, we will be using these two compounds. One is sodium sulfate Na2SO4 and barium chloride BaCl2. Once again, we have to make their aqueous solutions. So we take our barium chloride and before we use the spatula, should always clean it up thoroughly. Clean the spatula thoroughly so that there are no other crystals, right? And we take our test tube. Barium sulfate crystals are like, you can say, salt, common salt. So they are white in color crystals. So I'm going to add approximately half a spoon of barium sulfate crystal and so add distilled water. Let us see if we can dissolve it without using the glass rod. And when we add barium chloride to water, if you touch the test tube would have become cooler. So this is an example for endothermic reaction. It has used heat from the surrounding, so the test tube becomes cool. So our barium chloride solution is ready. It looks colorless. We have to make one more solution, that is of sodium sulfate. Sodium sulfate is also a white colored crystal. In terms of size, the crystals are much more smaller than barium chloride. So approximately half a spoon add distilled water. So this is our preparation for the reaction. Even sodium sulfate aqueous solution is colorless. What we have to do is we have to add them. This is our barium chloride. This is our sodium sulfate which we prepared. Both look exactly the same. Now I am going to add barium chloride to sodium sulfate. Observe carefully. That's it. Amazing, isn't it? As soon as we added barium chloride to sodium sulfate, you observed that a white colored substance is produced. This white colored substance is nothing but your precipitate. Is insoluble in the solution. It does not dissolve, therefore it comes out. This precipitate is nothing but your barium sulfate. Here both the ions of both the reactants got exchanged and in turn we got barium sulfate precipitate and a sodium chloride also as a product, which is dissolved here. The barium sulfate is not dissolved, therefore it will come out. Let me see, we add little more and you can see more of the product being formed. Let us now represent the double displacement reaction that we just witnessed using a chemical equation. So in the reaction, we had taken barium chloride solution BaCl2, which was aqueous AQ. To that we added our aqueous sodium sulfate solution Na2SO4 aqueous. In their solutions, they will produce the respective ions Ba2 plus and Cl minus. Similarly, sodium sulfate will produce Na plus and SO4 2 minus ions. And we observed that a white colored precipitate is formed. Now that is because in a double displacement reaction, ions of both the reactants get exchanged. In this case, barium ion will exchange with sulfate ion. A cation and an anion is essential. Similarly, sodium will get exchanged with chlorine. So we get a product barium sulfate, which is our white colored precipitate. The white color is barium sulfate, which we can also show as a downward arrow mark, and another product being sodium chloride, which is dissolved. So it is aqueous, and that is our double displacement equation. If you have to represent it mathematically, then we can show it as AB plus CD will give you AD plus CB. This will be the general form of double displacement reaction.